Hello and welcome back to another Unity Tiny video. In this video, we'll be learning how to do attack combinations and collisions with those attacks when hitting an enemy. So the attack combo, if you push J, you'll do a single attack. If you push J and then J again while doing that single attack, you'll do the 2-attack combo. And then if you push J a third time during the second attack, you'll do the 3rd attack in a row. Now, if you fall down here to where the enemy player is placed, we can do our attack combo on him and see that we get 3 different physic reactions onto the enemy when attacking him. If you try to do the first one over and over again, you can kind of get him to float in the air and then slam him to the side. So let's go ahead and go into the Unity project and see what we're going to do to set this up. Looking at the script files, you can see I added in an attack system. And then if we go to the scene and click on the player, you'll see that we have a new animations on our animation component. And if you go to the enemy sprite, you'll see that it has a component called Destructible. And it also has the velocity 2D and the rigid body 2D for applying the physics to it when attacking him. Destructible is just a tag, so you can tag things to know what can be hit with your damage abilities. You could take this out and only look for anything with a rigid body 2D and a velocity 2D if you want it to just be able to interact with anything regardless of whether or not it is tagged as destructible. But for this project, we'll use the destructible tag and tag everything that we want to interact with attacking. Later on, we can use a destructible and a health component together so that some items can have a health system and some items are destroyed with one hit. So let's go into the project I was working on in the last video. We can exit out of that. You can see it looks a little different from where we left off in the last project, and I think that's because I didn't save my scene before closing out of Unity, because I had to redraw my tiles, re-add my colliders, and I even had to recreate some components and redo all of my components. But it should be back at a state that is the same state that we left off in the last video. So the first thing we're going to want to do to start the attacking system, we'll go ahead and open the player input, because everything starts with the attacking system by pushing the J button, or whatever button you choose for your attack button. Inside of here, we need to set up the input for when pushing J to initiate an attack system. The way we'll do that is if ut.runtime.input.getKeyDown ut.core2d.keycode.j. Now inside of here, we'll be adding a new component to the entity called an attack component. But before we can do that, we need to create it. So let's go back into our Unity project, go into your components folder, create a new tiny component, and call it attack, because this is the component that will be added to a player to let the system know that it is something that is in the middle of an attack. And on our attack component, we'll need to add 2 fields to it. We'll add a float32 and call it a timer, and then we'll add a boolean and call it a combo step. The timer will be to track at what point during the attack system you're currently at. It's a way to let us know what frame of the sprite we are currently using. And then the combo step will be for when we push the attack button to iterate our attack system to the next step in our combo. Okay, so now that we have the component set up, let's go back into our script folder. And inside of here, we'll say if this.world.hasComponent, and what we will be checking is if the entity has a game attack component. But if you look back up at our this.world.forEach, we're not asking for an entity. So let's go ahead and add that in so that we can track and use the entity inside of the code. We'll say ut.entity, and we'll name it entity. And then in here we will say if this.world.hasComponent entity, And the component we are looking for is an attack component. We'll then say let ATK or attack equal this.world.getComponentData entity game.attack, and then on the attack component, this is if you push J and it already has the attack component, that means that we are already in the middle of an attack, so we need to iterate to the next step in the combo. So we'll say attack.comboStep. You can see it didn't show up in our drop-down box. That's because we need to save, go back into Unity, and come back into our script file, and it should be able to understand the field we are looking for. There we go, the error went away. So the combo step will be set to true. Then we'll say this.world.setComponentData onto the entity. The component we want to set is ATK. And then we'll want to return because that's all we want to do within this statement. But if the entity does not have an attack component, we'll want to add the component. So we'll say let attack equal new game.attack, and then this.world.addComponentData entity, and then attack. So now when you push the J key, a attack component will be added. If you push the J key again before the attack component is removed, the attack will be iterated to the next step in the combo. The next thing we're going to do is set up the attacking system. So go back into your Unity project and into your scripts folder. We'll create a new script called an attack system. It's a TypeScript system called attack system. Go ahead and open that file up. And inside of here, we have a good bit to type, but it's pretty simple. Alright, so in the onUpdate, we'll be wanting to look for all of the objects that have an attack component. So if it has a ut.entity, a game.attack, a game.animations, and then we'll name these entity, attack, and animations. And inside of here, we'll want to say if our attack.timer is equal to 0, that means the attack system is starting. So if the attack system is just starting, we'll just confirm that the combo step is false, so it does not automatically step to the next part of the combo. Then we'll want to start the animation. But we need to set up some more functions inside of our animation system to easily play the animations within the attack system. So we'll open up our animations file. If you're using Visual Studio Code, you can just go over here and double-click Animation System. If you're using normal Visual Studio, you can do the same thing, but I believe it's on this side of the screen and not this side. Alright, within the animation system, the first thing we're going to do is clean this up a bit by making a function called play movement animation. So we'll go down to here. Outside of the onUpdate, we'll create a new function called static play movement animation. And in here, we'll ask for a world and the animations, which is a game.animations, and a state, which will just be a number. Now inside of the static play movement animation, we'll be pretty much doing the same thing that is within here. So we can just go ahead and copy and paste these lines. Now we'll get rid of the this.world on the set entity enabled. And instead of true, false, and false, we'll say state equals 0, state equal 1, and state equal 2. So if we pass in a state of 0, this one will be set to true, and these will be set to false. 1, these will be false, and this one will be true. 2, these two will be false, and this one will be true. The next thing we'll want to do is, instead of saying animations.state equals 1, we'll set that to equal the state that we pass in. And then up here, we want to say if the animations.state is already equal to the state that we're passing in, we'll just return and do nothing. And then the last thing we'll want to do is reset the animation time, which is using this code. But I don't want to just paste this in. We'll actually create another function for resetting the animation time. So going below here, we'll say static reset animation time. And we'll need to pass in a world, which is a ut.world, and an animation, which is just going to be a ut.entity. Then we'll just copy and paste this and change some of the values. We'll change animations.jump to say animations. Get rid of the this.world to just be world. That's all we should have to do. Now in the play movement animations, we can reset the animation state using the function. So we can say animation system or this dot reset animation time. We'll pass in the world and the animation that we want to reset. And if you go up here, you'll see that we are only resetting the jump animation time. We could reset them all, but for now, we'll just keep resetting just the jump animation. You can click Alt-Shift-F to auto-organize your code. And now the next thing we'll want to do is replace all of this with the play movement animation function that we just set up. So, in here we have if movement.direction.x is equal to 0, we can go ahead and erase everything, and then we'll type animation system dot play movement animation this dot world animations and 1. Then here we can say else play the 0th animation. So this is idle and this is run. You can go down here and see run is state equal 0, idle is state equal 1. Moving down, we can say instead of this, we can just type in to play the jump animation, which is the second animation, 0, 1, and 2. We'll leave this in because this is for cycling between the last 2 frames of your cape to give the shaking cape in the wind animation while falling and jumping. Now we'll want to set up another function sort of like this one, but for playing the attack animations. So the first thing we'll want to do to start doing that is go back into your Unity project, go into your components folder, click on animations, and on the animations component, we'll add some new fields. We'll add attack 01, attack 02, and attack 03. So they're all going to be entity references. Attack 01, another entity reference, you can just click this and duplicate it and say attack 02, then duplicate it again and say attack 03. Now we need to set it up on the animation state also. So we'll add in this one, attack 01, attack 02, and attack 03. Then going to your player, we need to set up the attack animations. We can just duplicate the jump animation and call it attack animation 1. Then on here, let's add in the animations that we need. So the first sprite of the first animation is the 40-second sprite. So go ahead and drag that into here. And we'll go ahead and add all of the first set of attack animation sprites in. It'll be the first 6 sprites, so 1, 2, 3. The third one is this one. This is actually the sprite for the next animation. The first animation is just these 5 sprites. You can confirm that by going into the folder where you downloaded the sprites, go into the individual sprites folder, look at the name of the sprites. You can see that this one is Adventurer Attack 100, and then it goes over to Adventurer Attack 104. Then these are the next sprites for the second animation. Alright, now that you have these added in, we can just go ahead and duplicate this for the second animation, call it Attack Animation 2, and we'll add in the second attack animation's sprites. Which is Attack 200 through 05. So 1, 2, 3, 4, 5, 6 sprites. 1, and 6. Now for the third animation, it's the third attack, which is Attack 3 through Attack 305. So 1, 2, 3, 4, 5, 6. Now that we have our 3 attack animations set up, we can add them to the attack animation references. Then we can go back into our script folder. In the animation system, let's set up the function for playing the attack animation. So we'll say static play attack animation. And here we'll ask for a world, the animations, and a state again. Then the first thing we'll say is if we are already playing this animation, we want to return. So animations.state is equal to state, we'll return. Then we'll say we want to disable our movement animations, so we need to set up a function for disabling the movement animations. We could just copy and paste these and set them all to false, but we might as well set up a function because we'll be needing to do it in multiple places and it'll make our lives easier and our code will look cleaner. So we'll say static disable static disable movement animations, and we'll go ahead and make one for the attack animations also. And here we'll ask for a world, a ut.world, and animations, game.animations. Then we can just copy and paste this for the movement animations and set all of these to false. So false. Then we can just copy and paste this, call it disable attack animations. And instead of the run, idle, and jump, we'll say attack 01, attack 02, and attack 03. Then we can go back into our play attack animations function that we are setting up earlier. We'll say animation system, or we can just say this dot disable movement animations, pass in the world and the animations. Then we'll set the animation.state to the state that we're using for this call at the function. Then we'll set up a switch statement to hold the animation whose animation time will be wanting to reset on this play of the attack animation function. So we'll say let attack animation, which is a ut.entity. We'll set it to null, then we'll switch between the state that we passed into the function. We'll have a case for 3, 4, and 5. Now, if you don't know what a switch statement is, it's the same thing as an if statement, pretty much. We're saying if state is equal to 3, if state is equal to 4, and if state is equal to 5. So if the state is 3, we'll make attack animations equal to animations.attack01. Then 4 and 5 will be 2 and 3. Then here we'll say this dot reset animation time for world and attack animation. Then we'll want to enable the attack animation that we should be playing at this time. We can just copy and paste this into here. And instead of it being run, idle, and jump, we'll say attack 01, attack 02, and attack 03. And instead of 0, 1, and 2, we want 3, 4, and 5. You could also set them all to false here and then set the one to true here that you want to set to true. There's many ways you can do it, but this is the way we'll do it for now. If you want to do it a different way, feel free. So we have our play attack animation set up, reset animation time, disable movement and attack animations, play movement animations. We'll want to go back up to the on update for the animation system, and inside of here, above, if you're on the ground, will give us a few lines to work with. We'll want to say if the entity that we're currently working with has a attack component, we don't want to play any of the movement animations. So we'll say this.world.has component entity, which we are not looking for yet. So up here we'll say ut.entity and we'll name it entity. And then if that entity has a game.attack, we'll return and not play any of these animations and let another system handle the animations. So if it has the attack component, we return, and if it does not have an attack component, we want to disable all of the attack animations. So we'll say animation system.disable attack animations for this.world and animations. Now we need to set up which animations should play while doing the attack system. So we'll go back into the attack system that we started earlier, And now we have attack.combo step equals false. The next thing we'll want to do is say animation system dot play attack animation, this dot world animations. The attack animation that we want to play is attack 01, which is the state 3. We'll now create an else if, and on this else if we'll say if the animations.state is equal to 3, meaning we're already in the middle of doing the first attack, and our attack.timer is greater than or equal to 0.5, meaning the first attack is over, we'll want to iterate to the next step in the combo attack. To do that, we'll set up a function for doing it so we're not writing the same code multiple times. Go outside of your onUpdate function. We'll create a new function called static iterate combo. In here, we'll ask for a world, which is a ut.world, an entity, ut.entity, animations, game.animations, an attack, which is a game.attack, and last but not least, a state, which is a number. Then inside of here, we'll say if attack.combo step, meaning we hit the J button for performing a combo step, and then if the animations.state is equal to 5, meaning we are on the last state of the animation, and if that's true, we'll want to reset back to the beginning of the animation in case we are still pushing the attack button, so it doesn't do a step back to the idle frame, and it'll go right back to performing the first attack for a smoother attacking system. So that the animation states on the last step of the combo will reset the combo back to the beginning by saying attack.timer equals 0. Then attack.combo step will be set to false, so it doesn't step to the next step of the combo without having to push the J button again. And then we'll say animation system dot play attack animation, world animations, and state. Now, if you did not push the combo button, what we're going to do is remove the game.attack component, which will let the movement system's animations take back over. So we'll say world.remove component off of the entity. The component we want to remove is game.attack. Then we can go back up to here, and our else if we'll say attack system dot iterate combo, this dot world, entity, animations, attack, and 4. Which will make it play the animation 4 in the system or remove the component if you did not push J. Now if your animation state is equal to 4 and the time is above 1.2, we'll iterate to the 5th attack. And then if your animation state is equal to 5 and the time is 1.9 or greater, we'll iterate back to the first attack. We've done a lot of programming. Let's see if we can manage to play the game and watch our attack animations perform. So the game loaded up, you push J, it does the first attack, but does not go back to playing the attack animate or the non-attack animations. And if you push J multiple times, nothing happens. So going back into our project, we'll wait for the Unity editor to load back up, and we'll try to find where our mess up is at. Okay, what we forgot was actually pretty obvious. We need to be increasing our attack timer's time every time the on update increases. So underneath here, we'll say attack dot timer plus or equal to this dot scheduler dot delta time. And put it inside of your for each. Go back into your Unity project and let's play it again and see what happens. Click J and it does your first attack, then goes back to the idle animation. We'll click J twice, does the second animation, and we'll click it 3 times. And it does all 3 animations. Then if you push J repeatedly, it will cycle back to the first animation and keep doing the combo system. You can see the debug code that I added in to figure out the problem. Alright, let's go back into Unity. Unclick play. The next thing we're going to do is add in a rigid body enemy like you saw at the beginning of the video that we can add some hit impulse forces to based off which step in the combo we are currently at. So we'll go back into the, or first before we go back into the script folder, let's set up the enemy that we'll be attacking. We'll just create a new 2D object, a sprite. On here, we'll just put the animation for the first graphic of the player. We need to put in a layer sorting. We'll just put it on 10 to make sure it's at the top. Let's add in a box collider 2D. Let's edit the size of it. We'll make it 1. Put this at 0. Let's make this actually close to the top of his head, so we'll try 1.62. We'll do the same thing for the player actually. Looks like it's already a lot closer to the top of his head, but let's make it actually on the top. There we go, that's a little better. And then going back to the enemy sprite that we're creating after the box collider, let's add a rigid body 2D and a velocity 2D. On the rigid body 2D, make sure to make it dynamic. We'll freeze the rotation. Let's give it a friction of 0.5, 0 on restitution, so we don't want it to bounce, and we'll increase its density up to 10. We'll just try these values for now. We can play with them again later to try to get better results, or when we fine-tune the game for the feel that we want. Now that we have him set up, he should fall and hit the ground. So let's go back into our script folder, and we'll start setting up the impulse effect that's going to be applied to him. We'll do that by creating a new function called apply hit impulse. So we'll say static apply hit impulse. We'll be asking for a world, an entity, and an impulse force, which will be the direction the impulse will apply onto the character, which is going to be a vector 2. Inside of here, we'll say world.forEach, and we'll be looking for each object that has a destructible component, which we haven't set up yet, so let's go set that component up. Go into your components folder, we'll create a new tiny component and call it Destructible. go back into your scripts folder, we'll save, go into your project, and back into the scripts folder so that we can access Destructible. Then we'll say ut.entity, game.destructible, a ut.core2d, transform local position, and then we'll name these Destructible ENT, Destructible, and Detransform. So, Destructible ENT for Destructible Entity. Then we'll call this Dest Tag actually for Destructible Tag. And then Detransform for the Destructible's Transform. And here we'll say, let transform scale equal world.getComponentData from the entity that we passed into the function. The component that we want is the transform local scale, which is in UT-Core2D transform local scale. Now we want that entity's transform also. So we'll say let transform equal world.getComponentData off of the entity that we passed into the function, and then the UT's Core2D's transform local position. Now using this data, we'll say if transform.position.distance2 detransform.position is less than 2. And then if we need to set up a function for if you are facing the enemy or not. I was trying to do this with a dot product, but I was unable to combine the scale and the position to give a reliable result on the dot product. If somebody can figure that out for me, I would love to read it in the comments. So, for how we are going to be doing it for now, we'll go into our game services file, and inside of the game services, we'll set up a new function called isFacingEnemy, or isFacingEntity. So static isFacingEntity, and here we'll ask for a transform, which is a ut.core2d transform local position, and then the detransform, or we'll call it transform 1 and transform 2. That makes more sense. We'll also need the transform scale to let us know which way the character is facing. So we'll say transform 1 scale is a ut.core2d transform local scale. If you wanted to know if the other person is facing you and not just if you're facing him, you could bring in the scale for the second target also, but we're just looking to see if we are facing that entity and not if they are facing each other. So in here, we're going to return transform 1.position.x is greater than transform 2.position.x and transform scale.scale.x is equal to -1, or if transform 1's position.x is less than transform 2's position.x and transform 1's scale is equal to 1. So this is saying if transforms 1's positions x is greater than transform 2's positions x, meaning you're standing on the right side of transform 2, and transform 1's scales x is -1, meaning you are looking to the left, or if your x is less than the x of the second transform and your scales x is equal to 1, meaning you're looking to the right, this will be true if you are facing the character, so it'll return true or false based off if you're facing the entity or not. We'll save this file, go back into the attack system, and in here we'll say if game service dot is facing entity transform, detransform, and transform scale. And if that returns true, we'll say let scale equal world dot get component data from the entity, the ut.core2d dot transform local scale. Then we'll say let impulse equal new ut.physics2d dot add impulse 2d. Impulse dot impulse equals impulse force. Then world dot add component data onto the destructible ENT, and the data we want to add is the impulse. We actually don't need scale here. That was something I was using before, but now we aren't using it anymore. We can just take that out. So we just need impulse, impulse.impulse, and world add component data. That should be it for our apply hit impulse function that we set up. We'll go back up to here, and we need to set up when the impulse should actually be applied. To do that, we're going to say if attack.timer is greater than or equal to 0.2, and attack.timer is less than or equal to 0.5, so this time should be a little after the first attack starts and a little before it ends. We'll say attack system dot apply hit impulse this dot world entity and a new vector 2 of 0 and 5. Now we can just copy this, type else, paste it, and then we'll change 0.2 to 0.8 and this to 1.0. We'll make this a -7. Copy and paste it again. Change this to 1.3 to 1.8. And here we need to actually re-add in the scale thing that we removed earlier. So we'll say let scale equal this dot world dot get component data from the entity ut.core2d dot transform local scale, and the hit impulse that we want to apply is going to be 0 on the y, and on the x we're going to say 7 times scale.scale.x. Alright, that should be all we need to do to add the hit impulse onto the character that we are trying to attack. Let's go into here. We need to add the destructible component to the sprite. Now let's click play and see if that worked. You can push J, see your combo attack system is still working. We'll walk up to him, click J. He's getting an upward applied force to him. Let's click it twice. You can see he gets the upward and the downward force. Clicking it once, he falls down slowly. Doing it twice, he falls down fast. Let's move further away from him. You can see attacking farther away is not applying the damage. If you walk right next to him, you can see he slides a good bit. We'll still need to change some settings so he doesn't slide so much. But you can see if you're facing away from him and do the attack is not applied. Now let's do the third attack and see what it does. You can see the third attack slings him sideways because it is a slash attack and not an upwards or a downward attack. Alright, so the last thing we'll do is add a little more friction to the character so he does not constantly slide. Go back into your Unity project, unclick the play button, wait for Unity to reload up. So, for the friction, going on to here, you'll see that his friction is on 0.5, and the values you can use is between 0 and 1, so it's 50% friction, but he still seems to have 0 friction applied to him. The reason being is because if you go to these colliders, the friction is on 0. And how it works, it seems to multiply this friction by the other object who is interacting with that object. So 0 times 0.5 is always going to be 0. So we'll just increase the friction of the ground up to 1. Now if you click play, let's see if the friction is different. You can see he slides and then stops shortly after, and if you walk into him, he doesn't just constantly slide. He still slides, but not near as much. I hope you enjoyed this video. If you did, please consider liking and subscribing to the channel. It would really help me out, and it's the only bit of motivation I have to keep making these videos. But in the next video, we'll add in hit animations for when you get hit, and then we'll add in death animations and a health system. After that, we'll start to add in an AI control system for having some AI behavior on our enemies. But until then, have a wonderful day.